Alright, welcome everyone to our lesson today on expanding polynomials. Right, so today we'll first go over how to multiply binomials. So it's this stuff down here. And then using what we learned with binomials, we'll extend this to multiplying, multiple polynomials. Right, so we'll start small and eventually work our way to multiply a bunch of polynomials at once. So with that being said, let's just dive right into the binomials. Right, so we are asked to expand x plus 5 and times x plus 3. All expanding means is for us to multiply them together. We can quickly illustrate this using algebra tiles. So as you can see here, when we multiply the two x's together, we get an x squared right here. When we multiply this x and this 3, we get 3x tiles right here. When we multiply this x and this 5, we get 5x tiles. And lastly, when we multiply the constants together, so the 3 and the 5, we get 15 1 tiles. Which means that just based on algebra tiles alone, we can conclude that x plus 3 times x plus 5 gets us x squared first, and then we have 3x, right? So this is the 3x right here, and then we have 5x right there, so plus 5x, and lastly, we have 15 right here, right? 15, which means that we have x squared plus 8x plus 15. Right, and that's pretty much it. And now, to have a simpler diagram, we can use what we call a rectangle model. Right, so this is just streamlined algebra tiles. We have x and x here. So all we're doing here is multiplying this term by this term. So x times x, we get x squared. We have 3 times x now. Right, so in this tile right here, we have a 3 times x. That gets us 3x. Next, we get an x and a 5 for this square right here. We get 5x. And then lastly, we multiply this 5 and the 3 together to get this tile, which is 15. And once again, we reach the same conclusion. X squared plus 3x plus 5x plus 15, getting us x squared plus 8x plus 15. And now, as illustrated by both diagrams, x plus 5 times x plus 3 is x squared plus 3x plus 5x plus 15, getting us x squared plus 8x plus 15. Alright, and from here, we can actually notice a pattern. Alright, we don't need to rely on diagrams anymore because, as we can see, we can multiply the first term of the first binomial by the first term of the second binomial. So x times x, we get x squared. And then we multiply the first of the first binomial and the second term of the second binomial, we get 3x. Next, we take the second term, multiply to the first term, get 5x. And the second term, multiply to the second term, we get 15. Alright, so this is pretty much like a mental way to visualize the diagrams in your head. And then obviously, when we multiply everything, we just add everything up. Okay, with that being said, let's check out some examples here. So with example number 1, we're using the same thing here, right? So we multiply the first term to the first term. So x times x gets us x squared. We got the first term multiplied to the second term here. So x plus 2 is 2x. Okay, gotta be careful here now. The second term here is negative 4, right? We have a minus 4 in the bracket, which means we're multiplying it by negative 4. So negative 4 times x gets us negative 4x. Negative 4 times the 2 is negative 8. Right? And then we combine the like terms. X squared. Right here we have 2x minus 4x. 2 minus 4 is negative 2, which is that's the eraser, which is minus 2x minus 8. Right? So yeah, that's the answer. All the pattern is we're multiplying using the first term of the first binomial and then multiplying every other term. And with the same logic, we can actually work with more complicated polynomials. So in the second example here, right, once again, we take the first term, we multiply to the first term. So 2h plus h squared is 2h cubed. Then first term to the next term. So we have 2h plus 3, or 2h times 3h, getting us 6h squared. 2h times, oh look at that, negative 4, right? Remember the negative sign. So 2h times negative 4 is negative 8h. That's a weird one to say. Okay, next we go to second term times the first term. So 5 times h squared is 5h squared. And then 5 times 3h is 15h. And lastly, 5 times negative 4 or minus 4 is minus 20. Okay, once again, we just combine our like terms as usual. So we have 2h cubed right here. Okay, next we have a 6h squared and a 5h squared right here. So we add them up to get 11h squared. Next, with a single h, we have a minus 8h and a plus 15h. When we add them up, we get plus 7h, right? Minus 8 plus 15 is positive 7. And lastly, we have a 20 by its lonely self, getting us this answer. And now for the last example here, it looks super complicated, but luckily, it's not that bad. Okay, so once again, first term gets us 6x squared, so 3x times 2x. Okay, first term, second term, 3x times negative 4 again. So 3 times negative 4 is negative 12. So that's done. Now we go second term to the first term. Right, so we have plus 2xy, right? So it's y times 2x. Second term, so it's y times negative 4, which is minus 4y. Okay, lastly, third term times first term. Remember here, we have a negative sign. We multiply it to the 2x, giving us minus 2x. And then lastly, negative 1 times negative 4, getting us positive plus 4. Just kidding, it's not lastly. We still got more work to do. 3x plus 2y squared. We can write that as 3x plus 2y times 3x plus 2y. Okay, so here's what we have so far. Let's get going. So with the first clump of stuff, we can combine some like terms to make it more pleasing to the eye. We notice that we have minus 12x and minus 2x. Combining that, we get minus 14x. Actually, just kidding. That's all we can combine for now. That's okay. Minus y plus 4. All right, now we work on the second part. So right here, we notice it's a negative sign. Right? So this negative sign, and because this is a multiplication table here, this negative sign applies to all of this. Right? The negative sign doesn't just apply to the first term. It applies to everything here. So when we do this operation, we make sure everything is a bracket. Okay? So first term times first term, 3x times 3x, 9x squared. First term times the next term, 3x times 2y is 6xy. Okay. Second term times first term, we got 6xy again. And then last term times last term right here is 4x or 4y squared. Since we have a negative sign, we have to make sure everything gets converted properly. Oh, I really wish I had space for this. Okay, I'm gonna write slightly smaller here for the next line. Okay, so it's minus 9x squared minus 6xy minus 6xy again and minus 4y squared. Right? Because again, this negative sign applies to everything in here, which means that this negative sign applies to all those addition signs. Okay, now for the very last step, we combine all the like terms together. So we have x squared, which is 6 minus 9 is negative 3x squared. Next, we see x, 14x remains the same actually. There's no more 4x's. Next with the xy's, we have a bunch of those. So we got 2xy here, minus 6xy here, and then minus another 6xy here. Which means that 2 minus 6 gets us negative 10xy. Okay, next we have, that's it. All we have left is a y squared, a y, and a constant. So we'll just write that as minus 4y squared minus 4y plus 4. Alright, so that's pretty much it. So in a nutshell, as expanding, we are multiplying everything term by term, right? So let's go back to this question again. We're multiplying this term by this term, this term by this term. Okay, next we go by this term by this term, this term by this term, and then this term by this term, this term by this term. So we're just making sure every single term gets multiplied. So with that being said, here's some practice questions. So pause the video here, try them on your own, and then we'll go over the answers together. Alright, so hopefully you had a chance to do the questions. Let's go over the solutions quickly. Alright, so I'll just be speeding through this. So our game plan here is this term times this term, and then we times it by that, times it by that. Next, we multiply this term by this one, this one, this one, and then we multiply this one by this one by this one by this one. And then at the end we add everything together. We have negative 12 f to the power 4 plus 3 times f cubed plus 18 f squared plus, so now we're on the second term now, so this term times each of those terms, plus 12f cubed minus 3f squared minus 18f. Okay, last one. Remember, here's a negative 2 here. Multiply it as minus 8f squared plus 2f plus 12. Okay, let's clean this up because that looks absolutely disgusting. F to the power 4 is by itself. Okay, for the f squared, we had this one, this one. So we add them up to get 15 f cubed. Okay, for this f squared, we got this one, this one, this one. We have plus 18 minus 3 minus 8, getting us 7f squared. Lastly, we got an f and an f here. So minus 18 plus 2 is minus 16. F plus 12 by itself. Okay, that's that. Second question. Once again, so we have the first term multiplied by that, by that, by that. And then second term, this, this, this. Right, so all the same thing. We have 6v squared plus 2vw minus 4v. Okay, next set. Minus 15vw minus 10w squared plus 35w. Okay, this gets us 6v squared. Anything we have to worry about? Only one like terms. We got two of the vw's. So 2 minus 15 gets us minus 13. Vw minus 14v minus w squared plus 35w. Okay, so here's another complicated one. Plan. This term times this term times this term. Then this term, yeah, da-da-da, and then next term times that, while we expand this to be 4h minus 3k times 4h minus 3k. So you have 12h squared minus 18h plus 2hk minus 3k minus 4h plus 6 minus, in the bracket, Okay, well, just clean up the like terms right here. 4h squared minus 22h plus 2hk minus 3k plus 6. Okay, so keeping everything in a bracket, we have 16h squared right here. And then we have 3k times 4h, and then 4h times 3k. So we have minus 12kh, and then minus 12kh again, plus 3k times 3k, which is 9k squared. And then we expand this bracket out at the end. So once again, didn't leave myself that much room, but that's okay. Okay, so we have minus 16h. And we know from inside the bracket here, 12kh minus 12kh becomes plus 12kh plus 12kh minus 9k squared, which means that when we combine all the like terms together, let's just highlight the like terms. So we got h squared here, minus 16h squared, and then we have an hk, and actually surprisingly, that's all the like terms. Once again, so we have minus 4h squared minus 22h plus 24, 26hk plus, oh, nope, not plus, minus 9k squared minus 3k plus 6. So that was an absolute adventure. But as you can see, it's kind of satisfying to come out of like terms to have a somewhat short answer. With that being said, that's our lesson today. So keep practicing and stay hydrated.